Max, if you wouldn't mind getting rid of that pop-up, thanks. All right, welcome in everybody. Thanks for being here. We're just letting you connect. The webinar has been open, the live stream has been started. I'll just wait a few more seconds as I see the number of attendees rising. I'll start by saying good evening from Concordia University's Force Space, located on unceded Indigenous lands in Tiohtià:ke, Montreal. At Force Space, we work with Concordia students, staff, and faculty members, as well as their industry and community partners, to activate the various research projects, university initiatives, and courses via live events. We are therefore very pleased to welcome you into the AACEI-Montreal Section 3-minute thesis competition. That's a mouthful. Whether you're joining us in person or online, it's a pleasure to welcome you in, and congratulations in advance to the organizing committee and Dr. Mazdak Nikbat for putting this event together. To all of the competing students, of course, best of luck, and we are very much looking forward to your presentations. We hope you have lots of fun. I'll quickly just note a couple of things. First, we are live streaming to YouTube, so I will share that link in the chat in just a minute in case you want to share it across your own channels. Second, there will be a little time for questions after each thematic grouping, but if you have specific points of clarification type questions for each presenter, please pop it into the Q&A, and then our presenters will be able to write back to you publicly so that we might all view that exchange. And third, if you're in the space today, I'll remind you the importance of the microphone. Our friends on Zoom cannot hear us unless we use one, so please don't be shy about speaking into the mics. Finally, I'll be popping some SurveyMonkey links into the chat so that you can vote for your favorite presentations after each thematic grouping, as well as your 2 favorite poster presentations. So please keep the chat open and look out for those popping in there. Okay, it's now my pleasure to pass it over for the official welcome to Dena. Over to you.
Hello everyone, good afternoon. My name is Dena Shamsullahi, board member of AACEI-Montreal Section Student Committee. On behalf of our committee, we are truly delighted to welcome all of you here at Forte Space in Concordia, or through our online platforms such as Zoom and the YouTube channel of Forte Space. It's so exciting to have professionals from academia and industry, as well as the potential students gathered all here today for 3-minute thesis competition. Today marks our 4th annual 3-minute competition event, and we are proud to be able to host this event at this wonderful place with all of you. I would like to invite Professor Nikbat, Associate Professor in BC Department of Concordia University and member of AAC Board of Directors, to begin his speech.
Thank you very much, Dana. Thanks to all the student members of the committee. I just want to welcome everyone, the online audience of the event and the people that we have here in-house. I hope you enjoy the show. This is the 4th time we have this competition, and it's unbelievable how fast it grew from just a few presentations in one of our rooms into a now international event competition, and every year it's getting better and better. I just want to quickly thank AAC Montreal for their support, the trust and support, continuous support. Also Hatch, this is the 2nd year they're sponsoring the program, and SNC, that is our 2nd sponsor this year. Without this sponsorship and support, this was impossible. So back to you, Dana.
Thank you, Dr. Nikbat, for your interesting insights, and we appreciate your support and help during organizing this event. I would like to introduce AACEI-Montreal Section Student Committee members who generously volunteered to expand this event and enhance the connection between academia and industry. Our President, Hassan Bardare, the Social Director, Basma, and the Operation Director, Abdel Hadi. I would like to welcome our panelists, Dr. Ziad Zik, Assistant Professor in Concordia University, If you would like to address the audience, really appreciate it. And Mr. Ashwin Lala as the Regional Project Control Manager at Hatch.
Hello, everyone. Thank you very much. Hello, everyone. Thank you very much. I hope you guys can hear me. It's a pleasure to be here this evening. It's a wonderful place. It brings back a lot of memories. So just thank you very much for the invite, and hopefully have a great event. Thank you.
And Amin Jahanshahi, Commercial Manager at SNC Lavalin.
Hello, everyone. It's a great pleasure. I'm here, and I hope we have a wonderful discussion today. Thanks.
I would like to thank Professor Moselhi and Professor Karimi Dorabati for making time out of their busy schedule for attending to our meeting. I'm also extending my thanks to audiences and participants for attending to our event. We are so proud that we received many strong thesis abstracts from all top universities all around the world, which made the selection process very challenging. Until now, 12 finalists reached to this stage to present their projects. To cover more potential students, we add poster competition beside our main competition, which will be presented during the break time. We are grateful to our sponsors, Hatch and SNC Lavalin Company, for all of their generous supports. Unfortunately, Mr. Hajir Emrani couldn't join us today. I would like to invite Mr. Les McMullen, Global Director, Project Controls at Hatch, to address the audiences.
Well, thank you very much. It's a pleasure to be here today. We're very excited, very proud to be supporting the 3-minute thesis again this year. It really gives a great opportunity for the students to showcase their talent and their hard work. I'm the project director, global director of project controls at Hatch. Hatch was established in 1955. Today we're up to 10,000 employees working in more than 150 countries around the world. We're often voted yearly as one of Canada's best employers by Forbes. And our view is to create a positive change for our clients, for our employees, and in the communities that we're working around the world. We work in mining, infrastructure, energy, metals, and really work internationally, a very global organization. Our manifesto is passionately committed to pursuit of a better world through positive change. And when I think about that manifesto, it really reflects, I think, the thoughts of many of the students competing today. In the competition. And our mission is really exceptional, diverse teams combining vast engineering and business knowledge, applying them to the world's toughest challenges. And that's what I'm seeing in this competition. I'm seeing each of you presenting your thesis on a challenge, on a topic, and really putting your skills and knowledge and research to work. So that's very commendable. So in summary, thank you very much for having us here. I thank the professors of University here in Concordia, and of course the student committee who did a wonderful job in their publicity and publishing this on LinkedIn. And thanks to all of you who've taken the time to enter this competition. So I wish you all the very best in the next short time during the competition. Thank you.
Thank you, Mr. McMullen. I would like to invite our president, Hassan Bardare, to moderate the session.
Okay, thank you, Dana, for moderating the session. So before we go to the presentations, first of all, I review some general rules of the event. And we have technically 3 streams in the presentation part, which includes the digitalization and AI in construction. The second stream is urban and sustainable civil infrastructures. And finally, the last stream is digital twinning and robotic in construction. For the first one, we have 5 presenters. The second one, 4 presenters, and the last one, the 3 presenters. Okay. So we start with the first stream. At the end of each stream, we would have a question answer part, but each presenter should be ready for a question and answer part from our honored panelists here. So our first presenter is Mohammad Ali Khazen. I asked him to be prepared for the presentation for a minute. You would have 3 minutes to present your file, and then 4 minutes for a question and answer part. And our next presenter is Araham Martinez.
So I can start my presentation.
Yes, please.
The manufacturing industry increases its productivity faster than construction. The main reason is that the labor processes are directly connected to the machines, which makes monitoring them an easier process. But in construction, workers are the primary factor of labor productivity, and they are monitored by manual observation, which is an accurate method than controlling the machines. Not only in productivity, but also in safety. Manual observation of workers in a job site puts them in a more dangerous position than workers in a factory. My research is about developing a worker monitoring system to improve productivity and safety on a job site. The system enables a network of sensors to connect the job site with wireless network technology. It works by attaching Bluetooth beacons to workers' hard hat and wrist, and placing some number of fixed beacons on a job site. As workers move around the site, the beacons send signals to each other, which are processed by a machine learning model to capture the real-time location of the workers with the accuracy of less than a meter. To solve the privacy issue of tracking workers, I developed a construction activity dictionary model to identify the trade of the workers without knowing their names or IDs. So the identity of the workers remain anonymous during their work. The model uses the acceleration data that is coming from the Bluetooth beacon for activity prediction. It can also identify the productivity state of the crews with accuracy of more than 90% to show when they are idling, activating, or traveling. So the monitoring system provides information about the location of the workers, the construction activities that they are performing, and the building components that they are working on. On the basis of this information, a report is automatically generated to reveal performance indicators that are impossible for the superintendents to manage with a high volume of workforce by manual observation. As an example, the system quantifies the time spent by the workers in productive and non-productive zones. It further analyzes the working time to identify which type of construction tasks have been. As far as safety management, the incidence of danger zone proximity by the workers can be identified. For instance, the system can report the number of times that workers have approached the slab edges of a building. By using the monitoring system, we can analyze all transactions between workers and the construction environment to increase productivity on a job site and also create a safe environment for the workers. Thank you.
Thank you so much. So our honored panelists, if you have any questions, please. Yes.
Thank you, Mohammed. One question for you. Actually, how the model make a distinction between the task requiring more physical activities and the task with the less movement? Because at the end of the day, you're gonna actually measure the productivity by introducing this model, right?
That's
how construction tasks are introduced to your model?
I applied, there are three construction activities, plastering, painting, and masonry. So there are 3 construction activities and 5 construction tasks, which are bricklaying, placing mortar, and applying paint and plastering.
These are all repetitive tasks, right? That's why you wanna consider to introduce this task to the model.
That's true.
Thanks.
Sorry, Ashwin, do you have any questions?
Yeah, sure. First of all, Mohammed, that was very, very good presentation. Something that I was reading in the abstract, you mentioned about some kind of a previous literature that you had looked at. How did you compare that to what you have done, and what inspired you to come up with this type of model compared to what you had read earlier?
So there are three models in my study. Localization. In terms of localization, all of the previous studies, as far as I know, for the first time, I used Bluetooth beacons for all of the infrastructure for the system. So this makes the system very, very portable, and it reduces the cost substantially. So in terms of the localization, I use the Bluetooth beacons for the applicability of the system to the construction job site. And also I introduced body orientation and also activity detection in addition to the localization in order to have a better understanding of site activity.
Good, thank you.
Okay. Well, thanks, Mohammed. I have one other question. You mentioned that you're improving safety on site. How exactly is that going to happen? Are the crew going to be notified as an event is detected, or only after you've analyzed the data?
Mohammed?
My model is based on so I received it's not in real time, but when I receive the data, I analyze them and I can report which times the workers have approached the danger zone. And also one thing that is different from my study from the other studies, when I include the head orientation into the model, so I can reduce the false alarm if the worker is, for example, working in a danger zone, but he's already aware of that danger zone. So it reduces the number of false alarm to that workers.
Okay, thank you.
Thank you so much, Mohammed. Okay, our next presenter is Araham Martinez. Please be prepared to present your file. And the next presenter, Amit Ocha. Please be prepared to present your file after this. So, Araham, you have 1 minute to prepare for your file.
Please let me know if I can start.
Okay. Okay, you're ready to start?
Yes, I'm ready.
Yes, okay, please.
Hello, who of you is like my friend Ben, repeating the same mistakes several times without learning from previous experiences? Well, when I spoke with him last time, he had just broken up with another girlfriend again, and he confessed to me that he didn't know exactly what was causing all these breakups. Poor Ben. So I suggested to him to start asking himself, what are your expectations? What lessons can you learn from the past? What can you improve? And I also emphasized to him that he should go beyond the tip of the iceberg with this analysis to identify all the causes and avoid them in future. After doing this, today Ben is now involved in a new healthy relationship. And just like in Ben's case, in many construction projects, the same errors happen repeatedly without learning from previous projects. This has caused the construction industry to suffer from many pains for many years. For example, did you know that the construction sector has one of the highest degrees of corruption globally, with economical losses of up to 30% of the global annual production? And equally important is the fact that construction processes lack efficiency and struggle with poor process management, as happened with the Olympic State project in Montreal. On the top of that, even when construction organizations generate huge amounts of data daily, this data usually remains unused, and sometimes it is even lost. Now, let me tell you that as a researcher, I have identified that here is where my research work can contribute the most. And the overall idea is to extract these already available digital footprints from diverse data sources and put this information to work so that we can automatically discover actual construction-related processes by applying process mining algorithms. With this, one can identify performance issues and where they actually occur in the process to know what exactly to improve. Finally, after spotting this, stakeholders will become process aware and more accountable. Managers can make fact-based decisions, and organizations will boost their digital transformation, giving them a competitive advantage. To wrap my presentation up, my research will help to unveil process transparency, build trust among teams, and enrich organizational memory. This will lead to successful projects, just like the success that my friend Ben is having now with his new girlfriend. Thank you very much.
Thank you so much, Araham, for your presentation. So, our honored panelists, if you want to ask your question.
Hey, thank you very much, Abraham. Well presented. I wanted to ask about, you mentioned in your abstract, and didn't touch much on in the presentation though, about inductive and fuzzy minor algorithms. Can you just elaborate on that? What do you mean by those?
Sure. These two types of algorithms are the techniques that are used to extract event log data and then discover process models.
Thank you.
Okay, well, thanks, Araham. That was a nice story you told. Could you tell us a little bit more about what metrics specifically you're planning to focus on? And since you mentioned mining and Power BI, are you planning on having dashboards? What would it include?
Exactly. The idea after extracting and discovering the processes is to integrate through Python process mining for Python, and also our visuals, and then integrate these visuals to Power BI so that the companies can have conformance checking, process deviations, and many more indicators.
Then just a follow-up question, where is your data coming from? Do you already know?
Yes, it can be from information systems, 3D, 4D models in order to compare actual versus as planned and check also how delay or if there's cost overruns.
I mean, if you have any questions.
Thanks, Abraham, for well presentation. What about the uncertainties of the data? Because you gathered the data from a data bank, historical data. What about uncertainties? How do you actually tackle this one to predict your future trends?
Yeah, the idea of the uncertainties is after extracting the information from information systems or digital databases, is to order this information based on a standard extended executable standard, so that it can have that they can be structured and then extract process insights, as I mentioned.
Did you follow a standard density function or something like that? Which density function did you apply?
Right now, I'm at the beginning of my research, and I will be applying this into the industry so that I will be expecting to get more valuable and these distributions as well.
Thank you.
Thank you so much, Araham, for your presentation. So our next presenter is Amit Ocha. In the meantime, next presenter, Emilio J. Quintana, please be prepared for the next. And up to time you prepare, I ask the audiences to ask the question from the presenters in the question answer part in the chat box. By any chance, if any question doesn't answer, we can ask it at the end of each stream. In the audience voting part, we can bring to the question if we have time. So, Mr. Amit, are you ready?
Yes, I'm ready, but I cannot see the slides, my slides.
No worries, just
Okay. So can I start?
yes, please.
So, hi everyone. Today I'm going to present my thesis titled Human-Centric Non-Invasive Physiological Sensing System for Early Detection of Workers' Heat Stress in the Field. So, the construction workers face a serious risk of heat stress exposure in the construction industry. As we know, they have to work continuously in hot weather with long working hours and also including lack of shade and water. As such, construction workers are prone to heat stress exposure and its ominous, dangerous consequences. The pie chart in the slide shows that the construction industry in US solely accounts for 1/3 of the total industry heat-related fatalities, thereby showing the risks of heat stress exposure on workers and the importance of monitoring heat stress in construction. Currently, there are two major methods of monitoring heat stress in construction. The first method is subjective method, where we ask questions to the workers and based on their answers, we assess the heat stress exposure. And another method is environmental method, where the heat stress exposure is assessed upon the environmental parameters, that is airflow, temperature, and humidity. But the limitation with these methods is that they are prone to biases, they are time consuming, they are non-continuous, and the major limitation is that they do not account for worker physiological characteristics, as the worker physiological characteristics vary from person to person, and each person has different effect of heat stress exposure. So our point of departure is that in the light of limitation of current approaches, the big question remains: how can we generate the worker-centered heat stress monitoring approaches? So towards that end, my research objective methodology was in 3 phases. First was to develop a soft wireless sensing system for simultaneously collecting all the contributory physiological signals that are related to heat stress exposure. So second was to develop an interpretive ML model for automatic early detection of heat stress exposure for classifying whether the heat stress exposure is low, medium, or high. And the third was to validate the performance of the proposed wireless sensing system and heat stress prediction in the field. So we developed the sensor. Then to collect the data for developing the ML model, we conducted an experiment where subjects were required to do different construction tasks in 3 different climatic conditions in environmental chamber. So the 3 different climatic conditions were simulated to simulate to 3 different heat stress exposure condition by different temperature and humidity. We simulate different temperature and humidity. So we have checked the performance of the sensor, and our sensor have higher contact quality provided motion artifact-free sensing during manually applied motion as compared to the commercial sensors, proving our sensor is good. Also, the improved contact of our sensors causes decrease in impedance, so the sensor is good. And also, our performance accuracy of the developed model was 92%. Now our next phase is validating that performance of the model in the field. Thank you.
Thank you so much, Amit. So questions from our panelists?
Well, thank you, Amit. That was really interesting. My first question is, I see from the image that it looks like it's on the wrist. So how is this different or better from a smartwatch?
So technically, what we generally use is that smartwatch is not clinically proven or something like that, cannot be done in scientific experiment or something like that, because the measuring hertz or measuring frequency is different. So it cannot be used for research purposes. So the things that we generally use is called Empatica E4 band, which measures PPG at 60 hertz and EDA at 120 hertz and ST at 60 hertz. So that sensors we didn't use because construction has different motions, because there is different motion, the movement motion. So from that motion, there is artifact in that signal. So we cannot use that sensors properly, as they won't give good results. So because of that, we developed this sensor as it would be more helpful than the commercial sensors that are available, and would provide better contact with the skins, better motion artifact sensing. So as that, our sensor is better. Yeah.
Great, thank you.
That was a good presentation, Amit. Just in terms of, you mentioned about simulating the conditions which were in a simulator.
Yeah.
What was your accuracy? Did you kind of measure the accuracy within the simulator? In terms
So the thing is that, as I mentioned, we simulated the temperature in that chamber to do the experiments. To develop a machine learning model, we did that experiment as NIOS has 3 different conditions of temperature and humidity for low stress, high stress, and medium stress, heat stress exposure. So we used that. So workers were required to do that task in different climatic conditions, which says that they have different exposure. And based on that, we developed that model, and the performance accuracy of that model is 92%. But we have to validate that model in real construction sites or real working conditions. That's the next phase of my thesis.
Okay, thank you.
Thanks, Amit. Interesting topic, very important in terms of safety in construction sites.
Yeah.
How about the costs? Did you study about the cost of implementation of this system? It's going to be.
I think sorry. The costs for the sensors have been. I think we're discussing the sensor mainly. I think the sensor it's low cost. I think it's around 150 or less than that. We are decreasing the cost of it. We are focusing on that. I think that would be the next phase of our research. But we are using some soft electrodes, which we made it out in our collaboration with we made it in our lab. So we are using some soft AZ electrodes for measuring EDA and PPG, and then some flexible circuit boards for making that sensors. So I think the cost is now around 150 or 200. Now we are focusing on downing the cost.
Per person, right? Per person.
Per person, but we are downing the cost. Yeah.
Thanks.
Thank you so much, Amit, for your presentation and other panelists. So our next presenter is Mr. Emilio J. Quintana. Please, you have 1 minute to prepare for your presentation. And the next presenter would be Moises Carrasco.
I'm ready to start.
Okay, go ahead, please.
All right, hello everyone. My name is Emilio Quintana, and I'm a graduate student in the School of Building Construction at the Georgia Institute of Technology. It is a pleasure to be here, and thank you very much for this opportunity. The topic of this research is Industry 4.0 and the short-term outlook for the AEC industry workforce. Industry 4.0 describes the overall societal transformation caused by a variety of technologies and encompasses fields of study such as machine learning, computerization, automation, AI, and robotics. The motivation behind this research is that there's been news recently, including the Time article shown here, predicting that technology will replace millions of jobs. As someone who works and studies in the AEC industry, I ask the question, how will these technological shifts impact our industry? And is our industry going the way of agriculture, which used to employ 84% of the United States workforce and now employs just 1%, or are we headed in a different direction? So finding gaps in knowledge, this research aims to help fill those gaps. My hypothesis. According to the background research, jobs more at risk for automation should see low or declining growth and lower relative wages over the next several years. To test this hypothesis, I used United States Bureau of Labor Statistics data on wages, predicted number of new jobs, and the predicted growth rate of occupations over the next 10 years to create what I called an opportunity value for each occupation. I then analyzed these variables against data published by 2 University of Oxford professors, Frey and Osborne, which use a task-based model to calculate the probability occupations will become computerized, which they defined as job automation by means of computer-controlled equipment. As you can see here, it appeared that a relationship existed between Frey and Osborne's data and the opportunity value that I calculated. The data was tested for normality using KS tests, Shapiro-Wilk tests, QQ plots, and histograms. Normality was not found, so non-parametric test was next run. The Spearman rank correlation coefficient was calculated on the data, and the statistical significance was found. Finally, multicollinearity was tested for by calculating the variance inflation factors and conditional indices. Multicollinearity was not found. And these findings support the hypothesis. Next, using the BLS occupation classifiers, I compared all occupations to those in the AEC industry specifically. As you can see here, the AEC industry appears to be more at risk for computerization. However, the opportunity values appear to slightly favor the AEC industry. What this may suggest is that over the next 10 years or so, the AEC industry is at lower risk for automation than all occupations as a whole, but over the long term is perhaps more at risk. One of the most exciting things discovered in this research is the potential and need for future research. Instead of looking at the AEC industry as a whole, we could focus on just engineering or just HVAC contractors. Before occupations are completely replaced by technology, we're likely to see human-robot teams. And so there's a lot of need for research, and who better than the people here in this conference. Thank you very much for your time.
Thank you, Emilio. Okay, our honored panelists, do you have any questions?
Thank you, Emilio. That's very impressive. How did you come to any statistical figure regarding the link between opportunity value and probability of automation to be able to run your Monte Carlo analysis?
Well, first I plotted the points, and you can see the trend here in the middle graph. And then next, I used IBM SPSS to run the analysis for the Spearman rank correlation coefficient on each of the independent variables. And then seeing that there was a correlation between some of the variables, I wanted to check for multicollinearity, which is when I proceeded to do the VIF calculations and the conditional NC calculations.
Thanks.
Pleasure.
I don't really have a question, Emilio, but I just wanted to say it was well presented, a very good topic. Just starting to worry about my job in the long term. Thank you.
You and me both, but I think we'll be okay. I think we'll be all right.
Okay, well, I have a question, Emilio, but that was really interesting. It does create a lot of food for thought. You did mention reducing the study into more detailed groups and not just AEC. Have you found that there are certain areas where automation could create jobs instead of taking them away?
Absolutely. And I think what we're going to see is we're going to see a shift in how we view construction in general. We're going to see, I believe we might see an increase in modular construction. And so what jobs will that be created on a completely different level? And then, yeah, I think you're absolutely right. I think with the increase of technology, we might also see not necessarily a decrease in demand. We might see a continuous increase of demand, because as the human population grows, Bill and Melinda Gates Foundation letter said that we're going to be constantly, we're going to double our built environment in a short period of time. And so the demand might be increasing as right alongside the improvements in technology. So as construction improves in product efficiency, we might just be keeping up with the demand and not necessarily a downshift in the number of jobs.
Great, thank you.
Thank you. Okay, thank you, Emilio, for your presentation. So the last presentation, the first stream, would be by Moises Carrasco. Please, you have 1 minute to prepare. Up to that, I have 2 points to mention. First, guys, the presenters, please do not share your screen. Our team here, my colleagues, would share your screen, and you only need to do your presentation. So please have attention to that. And the second point I should say is please respect the 3-minute presentation, because after that we have to stop. It has effects on your criteria for our judgment. So, okay, Moises, are you ready?
Yeah, so I'm ready. So I should not share my screen, right?
No, our colleagues do that for you.
Oh, okay, I'm ready.
Okay.
Traditionally, the most common way of representing architectural design ideas has been by using drawings such as elevations and floor plans, along with realistic images called renderings. Even though these representations have precise measurements and defined materials, they can only be seen through two-dimensional means such as printing or computer screens. However, with the influence architecture has received from extended reality technologies such as augmented, virtual, and mixed reality, architects have a whole new range of possibilities for showcasing their projects. Among the three, mixed reality is the only one capable of actually merging the physical and digital worlds by providing clients with the critical, spatially referenced information that augments their knowledge of the design and lets them interact intuitively with the project. In that context, the Microsoft HoloLens is the only commercially available headset that provides that function, which is the reason why we chose it for this research. We used it to create an experiment that would help us assess the effectiveness of design review comparing MR versus 2D methods. We created an original architectural renovation design and gathered 42 participants who were divided into two groups. One used the HoloLens to look at a holographic 3D model, while the other group used floor plans and other 2D drawings. After they finished, they answered a questionnaire about the specifics of the design to assess the participants' percentage of comprehension and also to help us create a baseline to compare both methods. The results show that MR-based design review can effectively communicate 85% of the information to the client versus 70% provided by 2D media. Based on the analysis of participants and their answers, we were also able to determine that when it comes to understanding the general layout of a room or where activities can be performed, both MR and 2D are equally effective. However, MR really shines the most when clients had to understand how elements in the space interact with each other, like quickly identifying the specific materials and textures, such as the kitchen countertops and backsplash, visually understanding sizes in terms of height or thickness, and also understanding innate properties of materials like roughness or smoothness. 2D users, on the other hand, tended to focus only in the general functionality of the space. We see then that MR's advantage is the ability of allowing the user to explore a given space in a way that accurately mimics reality. However, 2D and MR are not mutually exclusive. MR headsets like the HoloLens do not need prior training and become the perfect tool to complement the shortcomings of traditional media, thus improving the architectural design review process. Thank you.
Okay, thank you so much, Moises. So, our panelists, if you have any questions.
Well, thank you, Moises. It's an interesting application. My first question, well, what kind of information is included in the survey besides the ones that you mentioned, size, properties of the material? What else are you asking the users?
Well, we were asking the participants about basically everything in the design. We asked them, for example, about the illumination. How many lamps do you see in the roof? What kind of tiles are you seeing in the floor? What's the color of, I don't know, like the color of the paint in the back of the kitchen, the materials of the stairs. We made sure that we went through the whole, like every aspect of the design in order to make sure that the person was actually getting what the design was about. You can see the original design in the slide is that little isometric. So we, like on purpose, we included like different levels. For example, that staircase in there, in order to make questions about like, is there like different levels? Are there stairs? What can you do in those spaces? Is there glass? Is there like, because all of that was on purpose so that we could make sure that the participant was actually noticing these like details, such as like the different materials of the floors, different materials of the ceiling and stuff like that.
Okay. And so what is the hope that more information will give the clients? What would you like that to create in practice?
Well, this is actually for me, well, I'm an architect, and for me, this is really important because if you use like, at the end, our conclusions kind of like went to the fact that if you use MR along with like some 2D drawings, such as the isometric, which is from what we gathered in the research, it was like the most important drawing that you could include in a 2D drawing set. So if you combine MR model with like this isometric, you can basically make the client understand naturally and intuitively like the design immediately. Which means that if you're an architect and you usually give a client like 3 design review meetings in order to like settle into one design and then continue to the next phase, those 3 review meetings could be reduced to only 1. So it will definitely reduce the time it takes to approve a design, and also it will reduce the uncertainty of the client, and it will increase like the confidence the client has in the architect, because the client is able to see an object in the real space, real scale, real color, and then that person can actually say, yes, I like it, no, I don't like it, and then he will be certain about what he wants and what he likes.
Thank you.
That's a very, very good presentation, Moses. Something that comes to mind, it's not a question, more of a comment. When you go into MR of what you're showing here, it certainly also helps in developing your estimate, your cost to develop something of this kind, either it's a building or whatever. Did you look into that? What kind of hope or it could bring in estimating?
Actually, we did, but we were mainly focusing on like understanding the design. But some of the applications that already exist in the MR world, they can already measure like the things that you're putting in the holograms. So it could help with the estimation, but I think it's still a little bit difficult to measure. Like I think more technology has to be developed for actually being able to know like precisely the sizes based on what you're looking at in the physical world. Yeah, for that you have to go to the model and measure it there, I think, so far.
Something else that kind of comes to mind is constructability. When you're able to see something as visual as MR provides you that edge, by looking at constructability of how you would construct either that room or that apartment or anything else of commercial construction, it certainly also helps a lot to be able to plan for construction.
Yes, it does. It actually, in that aspect, MR is super, super useful because you can basically put like, let's say I want to build a staircase that you're looking at in the screen, right? So you can basically put the hologram in the middle of the room and sort of like lay out the pieces and then just put it together on top of the hologram. And there has been like experiments done with this. Some pavilions architects have designed and they have assembled them just using MR. It's pretty possible. And actually it creates like better designs because you can, let's say, create a more complex shape. And then you just like bend the wood according to the hologram and then it becomes easier to build it. Yes.
Yeah, it helps with clashes and stuff that you can foresee beforehand.
Of course, yeah, it reduces errors a lot, yeah.
Thank you.
Thank you, Moises. Very interesting topic. Of course, MR gonna simplify actually and streamline the complex process, including the plans. And sometimes in industry, we want to see the change incorporated into the drawing. By employing the MR, how we can juxtapose, for example, two drawing and to see what's the difference in terms of the modification made to the drawing. Is there any way to make a report from this application? How the report look like?
Well, actually, because in this experiment, we were actually just testing the functionality of it. We didn't really develop an application for it. We were using SketchUp Viewer, which is an application that was already developed for the HoloLens. You can, in fact, look at, because, you know, like this is actually like a hologram that was placed on top of an actual room. So that that original design that you're looking at the screen was actually taken as a remodeling of a space, right? So some of the questions that we asked the participants were like, for example, like if they could, like we removed one of the windows in the design. And one of the questions was like, if they could count like how many windows there were on the new design, and most of the participants were able to notice that there was a window missing. So MR is actually, it's like pretty intuitive because like you put it on the space, it's the same size. So you can basically, it's like you're there, you know, like it's built, but then you can't touch it. So when it comes to like looking at past changes and new changes on top of each other, it's definitely possible as long as you put the models one on top of each other. Yes.
Maybe we can put some feature and the outcome give us the visibility, what's going on in terms of the change in the drawing. It's going to be super helpful during the design stage. Yeah, thanks.
Okay, thank you so much, Moises, for your presentation. This is the end of the stream 1. So we have now 2 minutes for audience voting. So Anna, if you don't mind to bring up the audience. Okay, perfect. You can see the link for voting here, guys. You have 2 minutes, the audience is online. And for the guys in person in the Force space, you can fill out the paper that my colleagues just gave you. Okay, after this, we go to the second stream. I pass the chair to my colleague, Abdul Hadi, to moderate the session. Thank you.
Now we are going to start our second stream, which is urban and sustainable civil infrastructure. We have 4 presenters. Our first presenter is Jinwoo Kim. Jinwoo, are you ready?
Yes, I'm ready.
Okay, you can start.
You might have had a bad experience during walking around your neighborhood because of physical defects and safety issues of urban space. Many previous research indicated that such elements, saying environmental stimuli, could negatively impact on our physical well-being and satisfaction of urban citizens. So, assessing and managing these elements is important to promote quality of urban citizens' life. One promising method to evaluate environmental stimuli is using biosignals. Recent development in wearable technology allow us to collect various biosignals such as walking pattern, heart rates, and electrical activity of the skins. Such signals could answer how people feel and how people react to surrounding environments. In this context, the overall research goal is to create a platform to collect best biosignals and propose the method showing distress of pedestrians. Such map could be used for mobility planning, especially for vulnerable populations such as elderly, children, pregnant, and disabled people to avoid negative environmental stimuli during their walking trips. Also, urban practitioners and governmental decision makers could use this information for community redesign and retrofits. Just simply think about it. In the near future, whenever you walk around your neighborhood with wearable sensors, your biosignals will be automatically collected and delivered to the cloud platform. You can simply check which part of your neighborhood creates the distress of pedestrians. My previous research examined the usefulness of biosignals. I designed and conducted 5 experiments in commercial and residential area. I also proposed new signal processing technique called seance detection analysis, and I also examined the multimodal machine learning techniques to better capture the distress of pedestrians. As a result, the collected biosignals could capture the negative environmental stimuli, such as houses with the broken features, dead animals, and sidewalk defections. Currently, I'm trying to test this method in daily life settings using 1,600 walking trips data. Although this approach still needs further development before being practical application, I expect that this approach will provide the opportunity for advancing urban built environment assessment and infrastructure management, and eventually it will promote neighborhood walkability and the feeling of satisfaction of urban space. Thank you.
Thank you, Kim. Now our judges, you can proceed with your questions.
Yes.
Okay, thanks, Jinwoo.
Yes.
So you're recommending that biosensors be used in urban planning. Who is going to wear those sensors and when?
So I already conducted these experiments with residents in the communities. So the actual residents will use the wearable sensors, and then only smartphone and wrist type sensor will be needed for these applications. And they can just wear these two sensors and go outside around their neighborhood, walk around there, and then their biosignals will be just automatically collected and delivered to the cloud platform. And then the proposed processing method will be automatically applied, and then they can just simply check the map showing distress of pedestrians.
So are there any data privacy issues from the city having all this information on biosensing from their citizens?
Yeah, that's really good questions. Privacy concerns always important. And so although I couldn't include about the privacy protection issue in my current research team, but I'm gonna include it. But many wearable sensing companies are trying to develop their own privacy protections algorithms. And also in my applications, for example, GPS trajectory could occur some privacy issues. So the developed map and application trying to aggregate all subjects the GPS trajectory, then the final outcomes does not showing their specific one trajectory. So then people cannot know which one is which GPS trajectory specifically from which individual or something like that. So yeah, that's really good questions.
Great. And last question, how will you know that the distress is due to an issue, a physical issue in the space and not something else?
Yes, so in my previous experiments, I wanted to know if really the residents feel some distress during their walking trips while wearing the sensors. So I developed I collaborate with one startup company, which is Dynamica app, to create an application. And then using that smartphone application, residents report their stress conditions or some events during their walking trips. Then I could know their status, mental status during walking trips. So it could be used for their some mental or physical status during their walking trips. Is that enough to your questions?
Yeah, thank you.
Thank you.
Okay, just a quick question, Jimbu, about have you thought about the frequency of these biosignals? Is it just something that you do occasionally, once in a while, or is it just a continuous process to be able to collect the biosignals from the participants, or have them do this regularly? Landscape changes, environment changes, people's distress may change from time to time. Have you given any thought about the frequency of this?
Yes, that's also really important, frequency. So our initial idea is just collect the best biosignals using the crowdsourcing. So we thought that the growing interest of their local communities, residents' interest on their community would be the key motivational factor to willingly contribute a lot of biosignals to us. So maybe in current settings, I'm trying to update the models within a day or within several hours iteratively, but how much time would be needed for the some frequency in terms of the frequency would be needed in the future research. So that's really good question. Is it good for your questions or?
Yeah, that's good.
Yeah.
Thank you.
Thank you, Jinwoo. Very impressive. Actually, my question is,
Yes.
You talk about the factors impacting the biosignal. Did you do any sensitivity analysis? Which factor play a more important role, and how do you actually do the sensitivity analysis in terms of the factors impacting the biosignaling?
So you mean factors means the stimuli, the environment, which is environment. Oh yes, of course. In current setting, this research has not been published as a paper, but I'm trying to check the sensitivity among these stimuli. For example, of course, broken houses significantly impact on pedestrians' biosignals and also construction site as well. But at the same time, no sidewalk or uneven sidewalks is just minor things. So it just slightly changes. But the interesting fact is that the participants population I'm also focusing on the young generation and also focusing on the elderly. So elderly, the response differently compared with the young generation. So there has been many different sensitivity things in this research. Thank you for your question. Yes.
Thanks.
Thank you, Geno.
Thank you very
Our
much.
next presenter is Shayan Georgiam. Shayan, are you ready?
Yes, I'm ready. Can you start now?
Wait until screen sharing.
Yes.
Okay, go ahead.
Thank you so much. Every year, municipalities and institutions see themselves with the need to upgrade, repair, or expand their utility systems. Millions of dollars are invested in these critical and necessary improvements or expansions. The traditional method of burying underground utilities has been used for many decades. Repeated excavations related to this method causes many problems, such as traffic congestion and business disruption, which can significantly increase the social cost. Multi-purpose utility tunnels are a good alternative for buried utilities, which are defined as underground utility doors containing one or more utility systems, permitting the installation, maintenance, and removal of the system without making street cuts or excavations. Despite their advantages, most countries do not use MUTs extensively because of their cost. Although initial construction cost of MUTs is higher than the traditional method, considering the social cost savings make them more competitive from the point of view of the total life cycle cost, especially in dense areas. Different factors should be carefully assessed to make the MUTs as an economic and reliable alternative. The construction method of MUTs, which can be classified in two main groups, cut and cover and trenchless method, is one of the most important factors that should be carefully assessed to have a successful MUT project. In my research, I did a stochastic 4D simulation of the MUT construction method using discrete image simulation to analyze the duration and cost of the MUT projects in different soil conditions and different size of the tunnels, compared different MUT construction methods and constructability assessment of the MUT projects using the 4D model, including the construction equipment. The methodology I used has 6 steps: analyzing the location and path of the MUT, selecting the construction method, defining the sequences and relations between different activities of the construction method, defining the probabilistic distribution of the duration and cost for each activity, 3D modeling of the MUT construction method, and 4D modeling of the construction method by linking the 3D model with the schedule. If I want to mention some primary results of my research, I analyzed macrotunneling and cut and cover methods and concluded that by increasing the diameter of the tunnel and the cohesiveness and hardness of the soil, the duration of the project will increase. The macrotunneling is more expensive but faster than cut and cover method. The macrotunneling is more sensitive to changes in the geotechnical condition and size of the MUT. And also I used the 4D model to consider the spatiotemporal conflicts and impacts of the MUT on surrounding areas. And at the end, we will be able to accurately decide how to put the utilities underground, how long it will take, how much it will cost, and what are the potential problems. I strongly believe that MUTs are sustainable, resilient, and important part of the smart city of the future. Thank you so much.
Thank you, Shayan. Now, if our judges have any questions.
Thank you for the presentation, Shayan. In your research, did you find one country or one state or province is more open to doing these type of work in terms of microtunneling, cut and cover than the traditional way of doing utilities?
Actually, I cannot say that. The most of the MUTs are done in China. There are lots of MUTs in China, but for the construction method they use, I found some projects in the literature in China and in European countries that they use cut and cover method. But exactly for using the microtunneling, I just find some projects in Germany. They use the microtunneling for MUT, and that's it. And most of the MUTs in the North America or Canada are done in university campus or some hospitals. That's what I find in the literature.
Okay, thank you.
Thank you.
Well, thanks, Cheyenne.
Thank you.
In your abstract, you mentioned looking at different sizes of tunnels. Have you
Yes.
seen that there are different feasibilities when there are different sizes or different types of soils? What were your results?
Actually, I consider 3 types of soils in my research so far, and 2 different sizes of the tunnels to just consider the effect of the size of the tunnel or the geotechnical condition that we have on the duration and cost of each activity, of each construction method. To just compare the effect of these different scenarios that we can have in the project. And as a result, as I mentioned in my presentation, of course, by increasing the size of the tunnel, the duration and cost of the tunnel will increase. And by increasing the hardness or the cohesiveness of the soil, again, the duration and cost will increase. But the most important part is we can analyze how they affect the cost or duration. For example, as I mentioned, I concluded that the microtunneling is very more sensitive than a cut and cover method to the changes in condition soils or size of the tunnels.
Thank you. And did you look at the cost of replacing existing infrastructure for the microtunnels?
The cost of, I couldn't hear you.
The cost of replacing existing infrastructure.
If I get your question right, you mean that the infrastructure, the utilities that we have before we start the project, yeah?
Yeah.
One of the reasons that they use microtunneling is that we can go very deep. So we can pass under the utilities that we currently have in the situation. So we don't need to remove them, you know? But for with open cut and cover method, we cannot go very deep, for example, 20 meters. That's one of the reasons we can use microtunneling also.
Okay, thank you.
Thank you. Thank you, Cheyenne.
Thank you. Yeah.
Impressive. Actually, in our current project in Montreal, we are confronting some actually MUT method in our existing tunnel. I just wonder to know, how did you define the probabilistic actually distribution of the duration and the cost? You mentioned you have some factors and you actually came to some actually duration of the cost. How did you come to probabilistic distribution? Because you're going to predict something, right?
Yes, exactly. But what I mean from the probabilistic, I mean that for each activity, we find some information on the literature. For example, when you want to just push one section of the tunnel into the ground. So we will not define the duration deterministic. We can say that the duration of this activity can be maximum 24 hours, minimum 12 hours, and the most probably it will be done in, I don't know, 20 hours. So the duration, we will define the duration of each activity in the probabilistic one. And for the cost, we just define the cost based on the labor hour, according to the research, according to the material, equipment, and labor that we have. We define a cost based on the labor hours. So we have the probabilistic time of the project. And if we use the cost by the unit of labor hour, also we will have the probabilistic cost. So at the end, we can come up with some results and can say that the maximum duration of this project is this much, minimum is this, and the average is this, and the same for the cost.
You apply triangular distribution for the time, but for the cost you apply the fixed rate as per
labor hour.
Okay, thanks.
Thanks, Shayan.
Thank you.
Our next presenter is Amireza Mahbour. Amireza, are you ready?
Yes, sir, I am. Can I start?
Okay, now you can start.
Hello, everyone. As you can see here, I have organized my presentation today in 3 main sections: problem statement, methodology, and outcomes and publications. My thesis aimed at developing frameworks based on data science to bridge the existing gaps that you can see under problem statement to improve network level pavement maintenance to the possible extent. Plugging each gap was basically one standalone research objective of my thesis. What I will do is introducing each research objective followed by its methodology and outcomes. The first objective was developing an optimal and sustainable investment strategy for pavement maintenance agencies. To this end, first I clustered the network under study into subnetworks based on climate and road functional class. Then I defined short-term, medium-term, and long-term maintenance periods, as well as 96 maintenance policies. And I applied these policies to each subnetwork under each maintenance period. In each case, I estimated the maintenance cost using machine learning algorithms and predicted the subnetwork condition using condition models. Then I found optimal policy using multi-criteria decision-making tools. To test the applicability of this framework, I applied it to the case of Iran road network and found optimal maintenance policies and maintenance periods for 6 subnetworks of different climates and road functional classes. The second objective was incorporation of climate change in maintenance policies. To this end, the methodology of the first research objective was used. However, it was applied to the specific case of Isfahan County in Iran, mainly because the climate of the county is transitioning from cold semi-desert to relatively warm semi-desert. This methodology revealed the increased maintenance costs in the Isfahan County as a result of climate change. The third research objective was developing a balance between cost and schedule in network level maintenance projects. This balance was achieved using soft computing algorithms, namely NSGA2 and differential evolution. Then the schedules proposed by each algorithm were contrasted in terms of cost and intensity of maintenance interventions. This contrast revealed how much money a pavement maintenance agency could save by improving its scheduling algorithms. The last and the fourth research objective was quantifying the benefits of collecting more data. To this end, the methodology of the third research objective was applied to the pavement network of the city of Oshawa. In addition to data size, the impacts of scheduling algorithms, pavement type, decision horizon, and network size were also investigated. The outcome of this study was benefit to cost ratios of larger data, and it happened because having larger data, we were able to increase the accuracy of our deterioration curves of pavements and increase our return on investment. Thank you so much.
Thanks, Amireza. Now our judges, if you have any questions.
Well, thanks, Amireza. That was really interesting. I'll focus on the first part where you applied models to predict condition. You mentioned Markov, and you did mention machine learning as well. So did you compare those two approaches?
Basically, I use the machine learning algorithms to predict the cost of maintenance policies and the Markov chain model to predict the condition of the pavement section. So these different methods were used to predict different parameters. So I was not able to compare Markov chain with machine learning because they were comparing different parameters.
Okay. And what kind of condition were you predicting for the pavements?
For the pavements, you can predict, it really depends on the data set that you have and your available parameters. In my case, in the first and second research objective, because I was using an Iranian data set, the available condition parameter that I had was the pavement condition index, or PCI. So I aimed at predicting PCI. But when it comes to the third and the fourth research objective, the available condition parameter that we had, or basically the city of Oshawa had, was the structural adequacy score. So we had to predict structural adequacy score.
Okay, great, thank you.
No problem.
Okay, very good presentation, Mireza.
Thank you.
Just a question in terms of, again, going back to what I talked about earlier in a previous presentation, is frequency. For this to be as accurate as possible, in your view, did you look into frequency of how many times or when does it you need to start doing these type of analysis?
Exactly. This is exactly what we have incorporated in our first and second research objective, because what we have defined, we have considered the frequency of maintenance interventions that have to be applied to pavement networks, and to this end, we, after consultations with pavement experts, we defined 3 categories of frequencies of pavement maintenance policies: short-term policies, medium-term policies, and long-term policies. And we compared the cost of each policy, we compared the condition of each policy, and then after developing an optimization model, we selected the most optimal frequency of maintenance.
Okay. I'm sure this is also very dependent on the seasons itself, depending if you're doing this type of model analysis in a cold climate or a warm climate. Your frequencies are going to range, of course.
For sure. And what we concluded at the end of the research objectives 1 and 2, we noticed that roads in Iran, if they are located in a warm zone, they need the most intense policies and shorter maintenance periods. And if they are located in a humid climate zone, they will need less intense maintenance policies and relatively longer maintenance periods. So definitely climate was a very important factor in our analysis.
Okay, thank you.
Thank you, sir.
Thank you, Amireza. Impressive. Actually, you talk about some factors like climate, road functional class, maintenance period, right?
Yeah.
To come to your analysis. But sometimes we need to stick to client's requirement, because in some, let's talk about walkway. Sometimes the clients request us from the aesthetic point of view. We design the actually permeable pavers instead of reinforced pavers. But we know that the permeable pavers, in terms of the maintainability and is more risky compared to reinforced concrete. So maybe in your future analysis, you should consider clients' requirements. So you talk about climate, road functional class, maintenance period, but we still need to comply with client requirements. Sometimes the clients stick us to design something which is not in favor of actually the climate or something like that. You know what I mean?
Yes, sir. And thank you so much for your very valuable comment. It is absolutely true. If there are some requirements by the clients, definitely we have to stick to them. But the main assumption in our analysis was that the client does not have specific requirements, and basically maybe there are so many parameters and he doesn't know which one is more important, or generally there is no plan. But for sure, if there are some requirements, definitely we have to stick to them. Thank you so much.
Thanks, Amireza.
Thanks, Amireza. The next presentation is of Danilo Caron. Danilo, are you ready?
Yes, I'm ready.
Just wait for screen sharing. You are ready to start?
Yes.
Okay, go ahead.
Why should the engineering industry do its part to advance reconciliation in Canada? I'll suggest 3 reasons. There are signs that society has recognized the harms done to Indigenous people and are ready to reconcile. The engineering industry is often at the center of projects that impact the well-being of Indigenous communities. And societal impacts can and should be factored into how we design and build. Working with the City of Vancouver and the University of British Columbia, both of which have committed to respond to the Truth and Reconciliation Commission's calls to action and to implement the United Nations Declaration on the Rights of Indigenous Peoples. These objectives will impact how engineering projects are planned and delivered. My research looks at what mechanisms within project delivery can better incorporate Indigenous values and ways of knowing. The City of Vancouver and UBC are on unceded Indigenous land, and they're taking different approaches to incorporating the values of the Musqueam, Squamish, and Tsleil-Waututh nations. Thesis City is a coastal adaptation design challenge with the City of Vancouver, in which 2 design teams are currently designing 5 sites around False Creek. The City of Vancouver included Indigenous values in the RFP and supported the design teams with decolonization and Indigenous perspectives workshops, which were developed and delivered by representatives of the Squamish and Tsleil-Waututh nations. Gateway is a new health building at UBC, which is scheduled to begin construction next spring. Gateway design team based their initial design on previous Musqueam engagement. UBC then facilitated a series of engagement sessions in which the feedback from Musqueam led to significant changes to Gateway's preliminary design, such as shifting the building 10 meters north to provide more space for Indigenous landscaping and ecological restoration. Project documents have been reviewed and interviews of project team members are currently being conducted. Other projects are being investigated as case studies to highlight additional methods proponents can utilize depending on the project context. What we've learned so far from Thesis City and Gateway is that some previous engagement insights can and should be applied to subsequent projects, but the local nation's relationship to the land is site-specific and relevant in different ways across the city. As tempting as it is to rush to a unified or to propose a unified project delivery framework, a context-specific approach is more appropriate. Strategies such as those utilized by Gateway and Thesis City can be applied, but for each, consideration needs to be paid to the proponent's commitment to reconciliation, the project team's experience and relationship to the Indigenous community, the context with respect to the territory, and the community's capacity. Understanding the limitations of current project delivery methods and leveraging the mechanisms within, engineers can better incorporate Indigenous values, local knowledge, and ways of knowing, and thus build relationships and contribute to reconciliation.
Thanks, Danilo. Now our judges, you can proceed with your questions.
Well, thanks, Danilo. That was really interesting. I like the examples from UBC and from the City of Vancouver. I used to live in Vancouver, so it's nice to hear about things that are happening there. And I know that probably the city and UBC have a special respect for First Nations, and they've been growing on different projects and working together. So my question to you is more philosophical. How do you see this being applied in other cities? What strategies should we use in RFPs and policies in urban planning so that this moves forward?
Thank you for the question. The philosophical nature of this research is kind of central, and part of it is prefaced on the motivations of advancing reconciliation. So these organizations that I'm doing a deep dive into, and they do have a long-standing and evolving relationship with the local nations, and it's very much seen as a work in progress and a long-term trust-building relationship. This is going to look different for all different organizations and municipalities, corporate sector as well. And there are lessons that we can learn in terms of how we can utilize RFPs. And these are the means and mechanisms that I'm interested in. RFPs are an example of capturing the intent of the proponent, including the key relationship and values of the Indigenous communities that are represented, Therefore, those who are bidding on the project have a better understanding of the outcomes that are expected. And those outcomes are going to be somewhat different than just the budget, the schedule, and the product. They will also include this fourth element, which, as I noted, is a societal goal of reimagining and reconciling our relationship with Indigenous people.
Great, thank you. Have you seen any infrastructure grants that specifically point to the need for collaboration with First Nations, or we haven't gotten there yet?
Can you just explain what you mean by infrastructure grants?
Well, there are, for example, the Federation of Canadian Municipalities, FCM, has grants specifically for training in asset management and capital programs that depend on cities having an asset management plan. So I'm thinking that this could be a similar framework, but for First Nations collaboration, where the proponent or the city has to have training, or they have to show support in that area in order to get federal funding and do other projects.
I'm not aware of federal related expectations within grants for a certain competency. However, as any proponent can actually assign competencies in their RFP. So, for example, they can request that a collaborative team, have experts in certain fields, and that's a very usual thing for the different types of projects there are. Having someone who can incorporate Indigenous values that are context specific, that could be a requirement that could find its way into project documents.
Great, thank you.
Thanks, Danilo. This is the end of stream 2, and now it's time for our audience to vote for this stream. You will see the link for the voting now. It's only for 2 minutes. Also, this is a kind reminder, if any of the audience has any questions, they can send them through chat. And we will ask them later at the end of the 3 streams.
Each 25, so you can just do summation.
There's 4 different non-fair, good, excellent. So maybe if your numbering system, if you can put, say, 5 is here, 10, 15, 20, then what we can do in your section, we can just fill it up.
Because I didn't bring my laptop.
Then there's aggregator and then it comes and picks up all three of yours. Waiting your day.
So maybe I can give you my.
Yeah. So if you come up with a scheme that these numbers in your mind here,
Yeah.
Poor, fair, good, excellent.
Okay. So we have poor, good, excellent.
Yeah, four. So poor, fair, good, excellent.
Okay. Thanks.
Well, thanks for voting. We are going to start the third stream, digital twinning and robotics in construction. We have three presenters. The first presenter is Cheyenne Shayesta. Cheyenne, are you ready?
Yes.
Okay, you can start.
Hello, everyone. My name is Cheyenne Shayesta. Today, I'm going to present my research titled An Evaluative Training Platform for Human-Robot Collaboration in Construction. As you may know, robots are emerging in many construction sites worldwide in different types and for different applications. But in construction, unlike other industries, robots and humans need to work together in shared workspaces. So working in a shared work environment can cause several safety issues for the workers. So it is very important for them to have the essential training to be prepared for working safely with the robots in construction sites. But in this regard, there are two problems or gaps. The first one is that there is a lack of effective training for human-robot collaboration in construction. And the second one is that there is no objective means to evaluate the effectiveness of a training process in general in construction. So the objective of this research is to develop an evaluative training platform for human-robot collaboration by integrating immersive virtual environments and physiological sensing. To do so, the first step is to make a virtual reality-based training environment for human-robot collaboration, in which a human-robot collaboration scenario, which was a bricklaying task, was simulated and the training was delivered to the workers. The second step was to use the cognitive load of the workers during the training process to evaluate their training. So we used three different physiological signals to measure the cognitive load, the EEG, EDA, and PPG. And we used the deep neural network architecture to differentiate different levels of cognitive load before and after receiving the training. And also the safety performance of the workers were monitored and rated by an expert before and after receiving the training. The results of the experiment showed that the provided training enhanced the safety performance of the workers after receiving the training. And also the predictive model resulted in a 92% accuracy in identifying two levels of cognitive load before and after receiving the training. So in conclusion, we can say that the findings of research showed the potential of the proposed training method as an evaluative training platform to enhance workers' safety performance during the human-robot collaboration. And also a correlation was observed between the level of cognitive load and the final safety performance of the workers. So we can say that we can use the cognitive load of the workers before or actually during the training process as a metric to evaluate the training process. Thank you.
Thanks, Cheyenne. Now, our judges, you can proceed with your questions.
So, good presentation, Shahin. Just a question with regards to your research. In the abstract, you mentioned you had 25 healthy subjects that you did this research with?
Yes.
Yeah. Okay. So was there any kind of, in terms of behavior initially before going into this training, before you're measuring their cognitive behavior or their load, was there any research done on how they're entering into the training session itself? What I mean by that is more like if you have intentions that you want to go get a training done, you may be more attentive and pay more attention in listening and learning. But if you're going with an intent that, well, what am I going to really benefit out of it? That may have impact on your results.
Okay, so all the subjects first had like the training, the task performance without the provided training, and after that the training were provided to them. So we actually measured the effect of the training on their cognitive load and also their safety performance. But before receiving the training, it was like just a task performance.
Okay, thank you.
Great, thanks, Shayan. How was safety performance measured?
So the training, so the training provided to the workers were basically based on the safe distance between the worker and the robot, and also some safety guidelines. So based on that training, the person that was like expert in safety in construction monitored the behavior. So for example, if the worker made an error during the task performance or actually didn't pay attention to what he was like provided during the training, there was some negative mark, and it was a base rating based on 1 to 5 based on their performance.
Okay, great. And when did you do the second test after the training? Was it right after?
Yes.
Did you do any testing a few days after to see if that knowledge stuck?
Yeah, that's a good point. I mean, actually, the long-term effect of the training is an important part of the training process. So that can be like a future step in this research. The research I presented, it was just like the immediate after that. But the long-term, for example, 2 weeks or 1 month after the training can also be a point to like investigate in the future.
Okay, great. Thank you.
Thanks, Shayan. Very good presentation. Actually, it seems HRC method perfectly matched for repetitive tasks like concrete pouring, dry wall installation, bolting, welding, so on and so forth, but is not been widely used to construction industry so far. What's the hindrance? Why we're not expecting a lot of employment of this method in our construction?
Yes, that's true. Yeah. So the construction base, because it's a little bit different from other industries. We see lots of robots in like other industries like manufacturing or car industries. The difference between construction and other industries is like because of the task. First of all, they're more dynamic. The environment is changing all the time. It's difficult to like program a robot or actually have a robot in a fixed space. So we need to relocate the robot. The tasks are dynamic. So it's a little bit more difficult. So with this current technology, the robots are mainly used for some limited repetitive labor-intensive task. So, and also this task, it was like a bricklaying, which is like a repetitive task. But in the future, probably with more advanced AI, it can be extended to other tasks and more complicated.
Thanks.
Thank you.
Thank you, Shane. Our next presenter is Yosheng Wang. Yosheng, are you ready?
Yes. Can you hear me?
Yes.
Okay, thank you.
You can start. You can start
Okay.
when you are ready.
All right, thanks. So, hi, I'm Yusheng Huang. Today, I'm going to talk about developing construction digital twin based on computer vision and real-time location system. Towards Industry 4, the construction sector is becoming digitalized. Digital twin is the future. So overall, the application of digital twins have the potential to improve construction throughout the project lifecycle. First, the digital twin helps better visualization, and the capability of integrating different types of data in one simulation model also helps improve the collaboration between different stakeholders. Moreover, with continuous real-time monitoring, more useful information can be obtained, which provides the possibilities of making predictions and optimizations. However, generating a digital twin of construction is difficult because the construction industry has a massive amount of data, which is difficult to collect in real time. In addition, it is also challenging to ensure the reliability of this data collected from the site. But fortunately, with the emerging technologies such as IoT, BIM, and AI, digital twins of construction becomes more practical, showing a promising future. The previous studies are mainly about exploring the feasibility of generating a construction digital twin. And most of these studies rely on point clouds or simple sensor data to update the simulation model. It is important to explore other sources of data capturing. Moreover, digital twins application for construction management are yet to measure. Not many studies have talked about generating digital twin for a construction site. So here we are trying to explore the possibility of developing high level of detail near real-time digital twins of construction sites using RTLS and computer vision, which assists the construction management regarding productivity and safety. A high LOD SPAN40 beam is used to generate the initial simulation model. In the physical space, the videos of the site and the position of the construction resources are captured by a camera and RTLS sensors, respectively. With the RTLS data, the position of the construction resources can be obtained. Extra processing is applied to smooth this data. And for the computer vision part, one of my colleagues built a method called YOLO53 to recognize the atomic activities of workers. By finding the prominent atomic activities in a temporal time window, we identify the microtasks. This information is extracted from computer vision, and RTLS are then become the inputs to update the digital twin to be as-built. By analyzing the as-built model, the progress of the construction activities is identified to perform progress monitoring and ultimately productivity analysis. In addition, the movement of the construction resources are also checked in the simulation model to perform proximity detection. With the historical data like the recorded trajectories and proximities, a risk heat map can be generated for the safety monitoring and risk prediction. And as a result, adjustment can be performed to improve the project management regarding productivity and safety. And this is the end of this presentation. Thank you.
Thank you, Xiesheng. Thank you. Now, our judges, you can proceed with your questions.
Great, thanks. Thanks, Xiesheng. You mentioned comparing to other studies. How does your approach improve on predictions of productivity? Do you have any numbers you can share with us?
I'm sorry for now because this research is still in the preliminary stage, and we are still trying to using the computer vision to reconstruct the digital twin. And then for now, we can't show any we haven't reached that productivity analysis. That step. But the whole idea is of digital twin is what you can do is to visualize and to review what happened in the reality. For example, there are some data that we cannot capture, like the productivity of specific workers. But with digital twin, we can create the virtual replica of the worker and show what he is doing in the virtual space. Then by this way, we can record the productivity of a worker, or even the productivity of a specific, like in our example, the form work. like we don't usually measure the productivity of a single framework. So this is what we call the, like, it is to the micros, like we are focusing on more on the small things rather than the whole project about the productivity we refer to.
Okay. So now that you're building the models, what would you say is most challenging at this point?
At this point, yeah, Chris, I'm sorry.
No, go ahead.
Okay. At this point, the most challenging thing for now is to match how to extract the data from how to extract useful information from the data we capture. Use, for example, the RTLS data and the videos in our example to be useful information to help us to rebuild this virtual replica, yeah.
Okay, thank you.
Okay, very good presentation, Yusheng. You mentioned about monitoring construction resources. Just wanted to really understand that in terms of digital twin. What did you mean by monitoring construction resources?
So now we the construction resources we consider have three parts. First is the construction equipment, like the telehandler, the crane, and something like that. And the other part is the workers. And the third part that is what we are going to do, but we haven't done yet, is the construction, like the materials.
Okay. Okay, that's good. Thank you.
Thank you, Yusheng. I have a question to you. Actually, what was your criteria to develop the risk heat map? You mentioned you developed risk heat map, which is based on the qualitative analysis. What was your criteria in terms of impact and likelihood?
Yes, for the risk heat map, for now we consider like there are four criteria that we consider. First is the occupancy of the construction site. We use, as you know, we have the position, like the position data we captured for the equipment and the workers, and then we create like from this location data we get the occupancy of the site. And the second is about the proximity. We try to find out in which area there are more proximities between the workers and the equipment. So this may also generate risks. And then also we have the paths, like the paths of the the paths of the equipment and the workers. By analyzing the trajectories of the workers and equipment, we try to find the typical path of the equipment and also for the worker. So we try to find whether there are some intersection between them. So if there are intersection, it means like there has more possibility in generating like the proximity or maybe the like hit by equipment accidents. And the fourth things that we consider is the speed of the equipment, like whether they may have a high speed area.
Did you run the simulation model to perform the proximity detection to your case study? Any quantitative data?
Yes, we have run the model for the proximity detection, and that actually I have, if you can find from the poster I provide, there is videos there showing the worker is like moving towards the equipment, and then it generates an alert based on the speed and the proximity, like the speed and the distance between the workers and equipment. And actually we have like this is like somehow like my previous work is about generating proximity alerts to workers and equipment based on their distance. And now we are trying to simulate these things rather than based on the RTLS data, but in the simulation model by considering multiple things.
Thanks.
Thanks, Yusheng. Next presenter is Azihili. Ozzy, are you here?
Yeah, I'm here. Yeah. Okay.
You can start when you are ready.
Oh, thank you. Hello, everyone. I will present my doctoral research titled Worker-Aware Human-Robot Co-Adaptation in Construction. So as you're probably aware, the construction industry has been suffering from several challenges over the last several decades, including the low productivity growth rate and the high number of fatalities. So to tackle these challenges, the construction industry has introduced the construction robots to the field. And due to the complexity of the construction environments, when implementing these robots, the worker supervision and collaboration are needed. So however, as shown in the slides, when the human-robot collaboration occurs in a shared workplace, it may raise the new challenges regarding the worker's safety. The safety challenges can be categorized into two groups: the physical safety challenges like collision caused by the lack of mutual understanding between robots and workers in terms of distance and movement directions, and the psychological safety challenges that can be caused by the unparalleled working performance of robots and the lack of trust into the robotic system. So to address these concerns, my thesis aims to establish an intelligent robotic perception system that allowed robots to understand their human partners' physical, psychological, and physiological states and co-adapt to their behaviors accordingly. So to this end, the first step of my research established a vision-based safety monitoring system to allow robots to monitor the worker-robot distance and assess the risk of collision with 95% reliability. And the second step of my research was about understanding the next move of workers by assessing the movement intentions of workers from their human kinematics with a deep convolutional pulse machine. And this step allowed robots to assess the worker's intention with around 90% accuracy. And third and fourth steps of the thesis develop a multimodal physiological computing mechanism to enable robots to assess workers' cognitive load levels from EEG signal and physical fatigue from EMG signal with around 86% accuracy. So then, by integrating the outputs of the first four steps, the final step of my research is to develop a robotic behavior model to enable the robot to adjust its performance to enhance the worker's physical and psychological safety. So as shown, the robot can plan its path to avoid any potential accidents with workers. And also, in the case of high cognitive load, the robot can reduce its working pace to match worker, so that the robot can follow workers' needs and there will be no additional pressure on the worker during the collaboration. So according to the reported results, the thesis established a human-robot co-adaptation mechanism that can allow workers and the robots to collaborate with a high level of safety and reliability. And also, the findings of the thesis should make an important contribution to the safe implementation of robots in the construction industry. And thank you. Yeah.
Thanks, Ozzy. Now our judges, you can proceed with your questions.
Yeah, thank you.
Thank you, Yuji. It seems Penn State University is very interested in HRC method in construction.
Yeah.
Actually, my question is, did you come to any figures showing the productivity improvement when employment this method in construction?
Yeah, actually, in this like presentation slides, I haven't shown the productivity growth, but in practice, for example, when we introduce the robotics to the system, then for example, in the bricklaying projects, the robots can improve the productivity of workers 3 times compared to the manual operation. Yeah. So yeah, that's the construction task for the bricklaying. But for the other construction tasks, we haven't tried to try if the robots, if the human robot collaboration can indeed improve the productivity. Yeah, maybe that's our future goal. In the future, we want to try the welding task as well as the rebar tying task by introducing robots to this task.
Thank you.
Thank you. It was a very good presentation. In terms of human and robot co-adaptation or collaboration, did you look into any type of costs that will be associated with this? How these robots are going to be developed, what they're going to cost, and how frequently they'll need any type of updates or improvements as we go?
Oh yeah, so actually, according to the literature review or some like realistic examples for the currently in the construction industry, I think we already have the construction robots like the SAM robot, the semi-automated mason robot, right? So yeah, so the robots can actually can somehow can improve the workers' productivity. And also like, yeah, yeah, that's the truth actually, that the cost of robots is expensive, but at the same time, it can reduce the safety challenges and increase the productivity. So yeah, I think that's a good deal to introduce the robots into the site. But in the future, maybe we also conduct another research to introduce some affordable robots. For example, to develop some like small robots, yeah, to monitor like to monitor the fault hazard detection. Yeah. So in the future, I think we can work on the affordable robots. Yeah, but now, yeah.
Okay. And the second question I have is, did you look into any type of ratio, human to robot ratio? You need one robot for 4 or 5 workers that are working in an area. Any kind of analysis done around that?
Oh yeah, actually that's a very good question and a very interesting topic. So for the conducted research I presented, actually is a single robot and a single worker. That's a one worker, one robot collaboration. But also like in future, that's also a very good like direction for the future investigation. Like for example, one worker have 2 collaborators, have 2 human collaborators, like also like the SAM robots, right? Yeah, has 2 collaborators. But still, we think in that case, like also we need to consider like we need to consider more factors into that collaboration strategy. For example, in that case, we will have human collaboration, human robot collaboration. Yeah, but that's a future. That's our future direction as well. Thank you.
Thank you.
Yeah.
Well, thanks, Yuji. That was very interesting. You mentioned that you're using the vision to measure distance more accurately. Yeah. Are you using those images for anything else?
Sorry. So you using these images for else? You mean for the other?
For the other steps besides distance.
Oh yeah. So actually, in the first study, we used the image to first measure distance and also measure the relation between workers and relation between workers and the robots to detect if the workers is collaborating with the robots. And in the second task, we use this image to extract the human, like if you can see in the slides. So in the second study, we extract the human body joints or the human skeleton from this image. So by using this image, we can also analyze the movement intention or like the human kinematics from these images. Yeah.
Okay, great. Thank you.
Yeah. Thank you.
Thank you, Azihi. This is the end of stream 3. Now we have 2 minutes for audience to vote for this stream. The link will be shared with you now. After voting, my colleague Basma will manage the next sessions.
You can take final questions, comment as anything you need. If you need to give the opportunity for Mr. McMillan to talk. Okay. We have 4 minutes for this. 4 minutes. 4 minutes because it's a break. مستر مقبول وهيحلق عشان احنا الساعة 5 35 دقيقة لازم نبدأ بريك.
Okay, so this is the end of the presentations session. So I would like to ask our panelists if they have any final questions or comments, any thoughts you would like to share with our participants about their presentations today.
Well, from my side, I'd just like to thank everyone who presented and congratulate the students. They were all really interesting presentations. I don't have any further questions. I'm not sure if any of the other panelists do, but thank you.
The same message to transfer to. Thank you for all your presentation. Very impressive ones. I wish you a very good job career in the future. That's it. Thanks.
Well, I do want to congratulate. It was a lot of effort put by yourselves. So excellent presentations, all 12 of you. It was very, very well done. Same note as what Amin mentioned. Wish you all the best. We will take a few minutes to do a bit of judging and we'll come back and give you the results. Thank you again.
Okay, thank you very much for your time and for being here with us today. I would like to invite Mr. McMullen from Hatch to give us a speech. So go ahead.
Yes, thank you very much for having me back. I wanted to come back and speak on behalf of AACEI-Montreal, one of the main benefactors of this competition. My board member, fellow board member, Hajir Amrani of SNC Lavalin is not here this evening, so I would like to say a few words on his behalf as such. First, I'd like to congratulate all of you. This has been a very impressive session, a great variety of topics, great research and application that's captured our attention and our imagination as we've sat and listened to your presentations. So congratulations to you all. You should be very proud of the work and the presentations. I would like to say a few words about AACE now. AACE is, I became a member myself right at the beginning of my career as an estimator. It's an association that was founded in 1956. It was a time when in the southern US, many large projects were underway, and a group of engineers got together in Northeast USA. And from that meeting, they founded this organization. It was originally the American Association of Cost Engineers. Over the years, it became international. And so AACE stands for the Association for the Advancement of Cost Engineering International. And it covers an umbrella of different disciplines, including capital cost estimating, operating cost estimating, planning and scheduling, cost management, change management, claims and analysis, earned value management, risk management. It covers a wide variety. I would like to acknowledge in the room today at the meeting, we do have a past president, Professor Osama Moselli, who is here this evening and has been very active through the years with the association. We also have Professor Nick Bach, who is on the board of directors and has been extremely active. And especially I'd like to thank our student committee of AACEI-Montreal who put this all together, just did an outstanding job, very impressive indeed. So thank you all, and their names were mentioned earlier in the presentation. AACE, as well as companies like Hatch and SNC, have been very supportive of the universities over the years. We've given many presentations at Concordia. We've also talked with the McGill University, University of Sherbrooke, ETS, Études Techniques Supérieures here in Montreal, and the École Polytechnique, the Montreal Engineering School as well. So there's been a very great culture of that, supporting these different universities. And AACE has also provided scholarships, the Montreal section, over the years. Myself, I was a past president for 10 years or more, and spent 4 years with the AACE International Board on their board of directors out of out of West Virginia, Morgantown, West Virginia. So I've been very closely associated with it. So normally when I'm talking to students, I like to encourage them, take a look at the AACEI.org website. Think about becoming a student member. It's a very small in terms of cost and huge in terms of benefits, networks, and educational material that you will benefit. So thank you all very much. I guess our judges will adjourn now to commensurate. So again, thank you all very much, and I'll hand it back to the student committee.
Thank you, Mr. Mukbalan. Thank you very much for being here. So now we're going to take a short break while the judging panelists can make their decision. But for us, we're going to see a video of our student committee. And then we're going to start the poster gallery. We have 9 posters and only 2 winners. So I invite the audience in Zoom and here in the 4th space to vote for the posters that they like. We have 9 posters and only 2 winners. So.
Infrastructure systems are vulnerable to extreme events and need to be quickly restored once they are damaged. However, due to the unanticipated event disruptions, the damage status of infrastructure components is uncertain and changes over time. To support rapid infrastructure restoration, my research aims to derive adaptive mathematical models that capture changes and uncertainties associated with infrastructure restoration. In my research, the methodology follows 3 steps. First, identifying up-to-date infrastructure damage status. Second, measuring infrastructure functionality under uncertainty. And lastly, forecasting future infrastructure restoration progress. In summary, this research facilitates decision makers to quickly identify infrastructure damage, reliably measure infrastructure performance, and better control the restoration progress.
Hi everyone, this is Shahrat Shakarian and I'm going to present my research with the title of Digital Twin-Enabled Facilities Predictive Maintenance using Machine Learning Algorithms and Sensory-Level Data. About 80% of the lifecycle costs of buildings are about operational costs which can be decreased by better maintenance management system. Different researchers have worked on different methods such as preventive maintenance, corrective maintenance, and predictive maintenance to improve facility maintenance of buildings. However, there is a lack of continuous monitoring method that uses operational data. So in this research, I try to propose a framework for intelligent facility management by using machine learning algorithms and real-time operational data. So I use different machine learning methods to develop predictive models to predict failures in the facilities, which resulted for more than 90% accuracy. Thank you so much.
Hello everyone. This thesis focuses on the issues with information exchange and monitoring between different construction disciplines within the concept of circular economy. To address this problem, the research investigates the information coupling between physical and digital assets across lifecycle phases of projects. Regarding the methodology, the research uses a series of taxonomy, coupling models, and information uses to address challenges with information monitoring and exchange from design for disassembly to end of life of an asset. For case study, the proposed information coupling model will be tested and validated in one of the regional schools in Quebec in order to see how the proposal can enhance the constructability and recovery of school buildings in the province. At the end, the outcome of the research proposes a taxonomy of information coupling for the concept of circular economy, as well as innovative model and principles for information monitoring exchange.
Hello everyone, thank you for giving me a chance to present my work. Let me start with the reasons why I choose this area. The first reason is the growing adaptations of modular and offsite construction MOC method, and the second one is that the increase in numbers of disputes in construction industry. The qualitative research method has been adapted in order to achieve the two objectives. Those are to develop a literature-based analysis framework and then to identify the common causes of litigation from MOC projects through the court case analysis. So as you can see in the bar chart, the results shows that the contract related and stakeholder related factors are the major sources of the litigation for modular and offsite construction projects in Canadian construction industry. Insight views and recommendations in relation to the contract terms to suit the MOC process has been made in these studies. I believe that this study has made contribution towards the knowledge of contract administration as well as the claim management. Thank you for your attention.
City population is growing every day and the consumption of energy is increasing too. The consumption of energy in the building is around 35%. And by the construction of a smart building, we can reduce the consumption of energy around 30%. The construction of a smart building, in my view, is the first step to the construction of a smart city. In my research, I used the questionnaire method in 5-point Likert scale, and I analyzed the barriers of the construction of a smart building in 6 main groups and 31 subgroups. And I can find some solution for these barriers. and the information and education, creating easy access to the new technology and creating desire to the new technology is the main one. Finally, I use the SPSS version 24 to analyze my research.
My name is Tabassum Mushtarimim. I'm presenting my literature overview on overcoming obstacles in beam-based multidisciplinary coordination. Recent years has seen significant research aiming at making the building information modeling or beam-based multidisciplinary coordination process more efficient. In the light of literature, obstacles having a greater impact in beam coordination are categorized into process, actor, task, context, and team respectively. Furthermore, schemes to elevate efficiency in construction ranging from shared situational awareness to machine learning are studied. I then draw the connection between these obstacles, their solutions, and the coordination phase where they're most applicable. This work identifies conflict resolution phase as the most challenging and in future will attempt to efficiently integrate automatic solution frameworks into beam authoring tools. This will result in reduced man-hour and cost in multidisciplinary coordination.
Everyone, I'm Salma Omrani, PhD student in engineering. My title is a literature review of offsite modular facade system with the integration of BIM and digital fabrication. The main objective of this research is design modular elements with the aim of digital fabrication, generative tools for form finding in regard to complex geometry. I use Grasshopper and relevant plugins for visualization and optimization. Galapagos for finding the attract point as the best solution for users' vision and distribute the modular elements on the facade to specify the user's vision. As the record of Galapagos, multiple fitness values were supplied and defined as the average and maximum vision, and DIVA for calculating and visualization the maximum natural light radiation in the desired zone. In the plan, refer to the first factors and analysis with the double glazed window. I appreciate your consideration.
How much do you know about radio frequency identification devices RFID in offsite construction? How can we solve the existing problems of using this technology in the construction industry? In this project, a framework is developed for integrating RFID with building information modeling in offsite construction to research the state of the art in the use of BIM and RFID and collaboration platforms to integrate these technologies in prefabricated buildings with using a design research methodology. The results of this research would improve the competitiveness of the Canadian prefabrication industry and will have a positive impact on cost management by streamlining processes.
Project finance plays a pivotal role in the development of infrastructure projects. Finance projects via this procedure have longer operation phase, which increases uncertainties and may cause breach of debt obligations. Given the advantages of project finance contracts for creditors, investors and large banks active in providing syndicated loans for such projects compete to offer better terms of loan to attract such form of deals. Thus, maximization of shareholder profitability is of utmost importance. The novelty of this research is that it proposes a new framework for optimization of debt service schedule with due regard to the maximum tolerable probability of default of shareholders from lenders' viewpoint. The applicability of the proposed method is shown on a 10 MW solar PV project utilizing genetic algorithm and particle swarm optimization for the proposed models optimization and validation processes.
Okay, so while we wait for our judging panelists, we have Dr. Mazdak Nekbacht. We would like to invite him to give us a few words.
Okay, thank you so much, Basma. And I just wanted to mention a few statistics about the event. As I mentioned briefly at the beginning, when we started 4 years ago, this event had 7 or 8 submissions, I think, in total. They were all coming from Concordia. We had to go knock on many doors the next time to get some more, basically, abstracts submitted for our second round. And now it's impressive. The fourth round of this event, we received 31 abstracts, and believe it or not, it was really, really hard to screen them and narrow them down into the 12 finalists. So for all of the 12 finalists who presented here, this is a big, big success. It was very competitive. We had to select 10 out of the 31 and open up a new stream for the posters that you just watched. One quick message to the people who are in the poster session. Some of these works were at the earlier stages of the research and development. We definitely want to see them the next year when the development has had better improvement to resubmit the abstracts, and hopefully the next year we can have you as the presenters, the 3-minute presenters. Before handing it over to the judges, I also want to thank very warmly and sincerely the student committees, and Basma, Dana, Hassan, and Abdul Hadi. They did a fantastic job, outstanding in terms of basically logistics and putting the videos, compiling the videos, everything that you see here. These are the superstars who made it happen. So the judges are here. I won't let you wait more than this, and I pass it over to maybe Dr. Zidzik.
Great, thank you, Mazdak. So we have the results here. It was a difficult discussion. The scores were very similar, but we came to an agreement. And we'd like to congratulate everyone that participated and thank you for joining us today. So we have the 3 places. We'll start by 3rd place. So congratulations, Danilo Karan. It was a very interesting presentation, out of the box. Congratulations, Danilo, on 3rd place. And in 2nd, we have Cheyenne Georgian. Again, congratulations, very good. In 1st place, little drum roll, Amit Ocha, very good presentation, thank you. Okay, I'll give it back to Mazdak.
All right, thank you so much. So maybe I can ask each of the 3 judges to give a few words about each of the presentations, and then maybe if you have time to hear from the basically the winners. The winners, heads up, you know that you will be invited to present an extended version of your presentation in the AACE monthly meeting. Perhaps this is going to happen in the month of January. So stay tuned, and that's where you receive your awards. So you have to wait a bit more. I'm going to return it back to Rebecca for some remarks on the 3 presentations.
Okay. Well, thanks, Mazdak. I'd say in general, these 3 presented very well. They also had advanced stage of their research and were able to give good details. I'd say Amit, there was specific technologies that were interesting and we could see it was very practical. For Cheyenne, I think we also saw that the practice of the multipurpose utility tunnels could be something we could see nowadays already, and there are solutions that you're proposing that are interesting to us now. And for Danilo, it was different from the others, clearly, but it did make us think about how to improve the RFP process, and we look forward to more from each of these students.
Thank you, Rebecca. Well, I would just like to kind of echo the same message what Rebecca said, starting off from Danilo, very out of the box, very different. So that kind of really stood out for us. We thought you presented extremely well. Actually, one of the best presenters. Had a very different topic, and congratulations on that. In company that I work for currently, we're very, very involved in Indigenous community and really put that in the forefront right in the beginning before we get into any type of project or engagement, as we call it. So well done. If you go back to the number 2, we had Cheyenne. Again, very, very well presented, very interesting topic about 4D simulation and multi-purpose utility tunnels. Again, something that I can relate to. I mean, we are doing a lot of 4D simulation, not so much within the MUT right now, but we are using 4D simulation, specifically the software called Synchro 4D, that's the Bentley-based software. And we use that to do a lot of our simulation, which connects our 3D models to the schedules itself. So I can relate to that topic as well. And the first one, of course, Amit, congratulations again. Human-centric, non-invasive psychological sensing of work, heat, stress. And I personally can relate to it again because I spent 7 years in the Middle East and I really understand what heat stress is. And you have a very innovative way of measuring it and to be able to make sure that the workers are safe. So again, very interesting topic and well presented. Thank you to all 3 of you. Congratulations.
Well, congratulations to all of you guys. Actually, you did had a very good presentation. The score were pretty close, and we had a lot of actually challenge to pick the best one. But congratulations to the 3 winners. These were the topic was very practical, and I'm looking forward to listen to your extended version of your abstracts. Thank you.
Thank you again, the 3 judges, Amin, Ashwin, and Rebecca. You were outstanding, very great process of asking questions and judgment. The time is unfortunately up. I was really hopeful that we can hear from the 3 winners, but maybe we can wait until the January monthly meeting of AACE when we listen to the extended version of their presentations. So congratulations again to all 12 students who made it to this final round, and special congrats to the 3 winners. Thank you so much to Fourth Space. Special thanks to Fourth Space. Anna, you're the best, and see you next time, hopefully. Back to you, Anna.
All right, thanks very much, everyone. Sorry, you know when you're clicking a bunch of things at the same time and trying to speak? Well, here we are. It's the end of a long day. Thank you so much for coming in person and being here with us. And those of you who joined online, obviously, we treasure your participation. Thank you for voting for all the People's Choice Awards as well. I'm thinking those might be shared at a later date. I'm not exactly sure because we have to combine the scores from online and the scores taken in person. But a tremendous thank you to the organizing committee, as Mazak already suggested, Hassan, Belhadi, Basma. I hope I didn't miss anybody. Spearheaded by Dr. Mazak. We really appreciate our judges, sponsors, supporters, audience members, and of course the competitors. You did a tremendous amount of work, and we appreciate you sharing your research with us. So, unless I'm to pass it back to someone for a final word, we will be closing up the webinar. And I'm not seeing any excited waving of arms, so...
If I can only add one sentence, I forgot to mention the winners of the posters will be announced in the coming days. We were going to send the poster presentations to the 3 judges. We want to take their basically vote on that as well. We already have the vote of the audience, and accordingly we finalize the decision, and we'll announce it very soon. Thank you again, everybody who participated in this event, and have a good day.
Wonderful. Good night, everyone.